Hello everybody and welcome back. Today we are continuing with our Unit 3 by talking about weathering. So we're on Unit 3, lesson number 5. Yep, lesson number 5. As always, you should have downloaded your interactive notebook pages for the day. And we are going to jump right into this lesson on weathering that goes along with the notes in those pages. So we've already talked about weathering. And we've mentioned it in passing in relation to your rock cycle. So if we just recall back to our very first lessons of this unit where we talked about sedimentary rock, which is formed from sediments being piled on top of one another, compacted and cemented down. Those sediments come from the weathering of rock. And we've already talked about weathering being just the breakdown of rock, but we're going to go into it a little bit more in depth today. So first we're going to define weathering, which is the set of physical and chemical processes that break rock into smaller pieces. And there's two different types of weathering we have to know about. The first is chemical weathering. So this is when minerals in a rock are dissolved or chemically changed. So something about their chemistry is going to be altered. Physical weathering is when minerals are not chemically changed, but the rock fragments simply break off of the solid rock. So physical weathering would be more like a rock getting kind of beaten up by water, or somebody stepping on a rock and it crumbling a little bit, or being exposed to pressure. Those kinds of things would be physical. You're not going to change the chemical composition of it. You're just going to be breaking it into smaller pieces. And then this weathering is what causes our soil formation. So we talked about soil yesterday, and remember that soil starts with the weathering of the bedrock, which is the parent material on the very bottom layers. So as weathering happens over time, you get that soil formation on top of that parent material. And we can have fine grain soil, medium grain, and coarse grain soil as well. And just a reminder from yesterday, soil textures are based off the particle sizes of the particles that are in soil. So remember, our finest one is clay. So a high clay content would be a very fine soil. Medium is silt, and then coarse would be sand. So a sandy soil you would expect to be more coarse. So let's talk about the differences between chemical and physical weathering, since that's what we're focused on today. So in the left-hand column, we've got chemical weathering, and these are the things that affect chemical weathering. So number one is water. Water can dissolve minerals within a rock, and if it's dissolving minerals, then you are changing the chemical composition of that rock. It's chemical weathering. Oxygen also will react with substances in a reaction called oxidation, and it will change rocks on a chemical level. So anytime we have a reaction of oxygen, that's going to be a chemical weathering. CO2, or carbon dioxide, is released by living organisms and will form carbonic acid that will dissolve minerals. So carbonic acid has a low pH level, and anytime you have a substance with a lower pH, it acts as an acid and can dissolve away minerals. Acid precipitation, or acid rain, that's a lower pH of water, and again, we get that from pollutants such as carbon dioxide in the atmosphere. It will undergo a chemical change and lower the pH of the water that falls to the earth as precipitation, and it can actually cause a detrimental effect. So we can get dissolving of minerals in rocks this way. And also temperature. Temperature will influence the rate of chemical reactions that are taking place during chemical weathering. Now let's take a look at physical weathering. Again, physical weathering, we're not changing anything about the chemical composition of the rocks, just breaking it down into smaller pieces. So something that will affect physical weathering is also temperature. So temperature can affect both chemical and physical weathering. So an example of this is a really good one called frost wedging. And I don't see the word on this slide, but it's called frost wedging. And that's just when, if you think about in a colder climates or in the winter months, as water falls in the form of precipitation, so rain will fall and get into different cracks into rocks or even the pavement overnight, or when the temperature drops down and gets cold, that water will freeze. And as the water freezes, the water will expand. And as it expands out, it will actually cause cracks in the pavement or the rock. And again, that's called frost wedging, but that is an example of physical weathering. So an example of this that you could see is the formation of potholes in the roads. I went to App State University, which is in the mountains, and every single year, I swear, guys, the roads up there got worse and worse and worse. There was a lot of frost wedging going on. But also pressure will affect physical weathering. So removing rocks above will decrease pressure and allows different layers to be peeled off. And again, layers being peeled off or moved away is physical weathering. So an example here, removing rock from a mine can decrease pressure and cause large pieces of rock to explode off of walls and of mines, tunnels, burying workers. So that's actually kind of scary. So when we think about, like, if you were thinking about a gold mine, obviously with newer technology things are a little bit safer, but back in the day of the gold rush, people would go in deep into these mines in order to get the gold out, and as they would mine and tunnel through, they would relieve that pressure out of the tunnels. And because that pressure was relieved, a lot of those rocks would just kind of like fall off the walls and kind of slough off. And this was like a physical weathering event, and it would bury miners in the mines themselves. And that's actually really scary. Not for me. not a situation I would ever want to be in. So climate can also affect weathering. So things like precipitation, temperature, and evaporation. Temperature and precipitation will have the greatest effect on weathering. Chemical weathering tends to occur in areas with warm temperatures, high rainfall, and lush vegetation. And part of that is because anytime you have live organisms will do something called biomechanical weathering, and also they can excrete different acids and things that will break down rock and change the chemical composition. Physical weathering tends to occur in cool, dry areas, especially where repeated freezing and thawing occurs. So physical weathering, that frost wedging, occurs in areas that tend to be cooler and drier. Little or no chemical weathering occurs in areas that are frigid, so with very cold temperatures all year round. And that's just because, first of all, cold weather will kind of slow down chemical reactions, so we don't see as much chemical weathering happening in colder temperatures. Rock type and surface area also contribute to weathering. So weathering will depend on how hard or resistant rock is. So remember in that video we watched a couple days ago, sedimentary rocks are more easily weathered because they tend to crumble. Remember, they're made of sediments, so they're a little bit softer and more easily weathered down. And then mechanical weathering breaks rocks up into smaller pieces, which then will increase the surface area. So increasing surface area means there's just more area available to be broken down. So if there's more area available to be broken down, then more weathering will in turn occur. Just a couple other variables. Rocks on slopes are more likely to move, which will expose underlying rocks to more weathering. And then organic matter and plant roots will release carbon dioxide. So when that carbon dioxide is released, remember that will combine to produce carbonic acid, which is a lower pH, which will increase chemical weathering. So anytime we are changing the substance of a rock or a mineral on a chemical level, it's chemical weathering. And anytime we are just breaking down the rock physically, so nothing about the rock's chemical composition is actually going to be changing, we are doing physical weathering. Okay, and that's all I have for you guys today. We just need to know the difference between chemical and physical weathering. And if you have any questions, let me know. And if not, I will see you in the next one.